阿强，你来哦！妈的，那死啊！这个地方刚 miss 一点了，他一直跟那个破开的在讲。
Good afternoon, all.
看时间。关那个。
Hello. Afternoon.
Morning.
Morning. How are you guys? Feeling good?
No.
No.
Diary.
Good. That will be the standard answer. Started from the week 4, week 5, the answer will be no. Okay, so before we start our class, I wanted to ask your opinions. So I would like to have a midterm test in the week 9 or week 10, week 15.
15.
15.
Week 15.
Next semester.
Can next semester. See you next semester again.
Yeah.
Can. See you next week. Either week 9 or week 10 because week 11 will be your assignment submission. So yeah. I'd like to double confirm with you. Do you have a class on? Because in the week 9, Thursday is a public holiday, National Day, 31st of. So, do you prefer a Wednesday or Friday?
Friday.
Wednesday or Friday? Night. No. Physical.
Open book.
Friday. What's the time? Either 6 or 6:30. It depends on your timetable. I need to check.
Your class until 6 or?
If you don't have a class like evenings, then I will double check with other groups. If they don't have a class at evenings, then I probably make it like 5 or 6. So it depends. So I want to double check with your timetable first. Can you check your timetable? Since there's no response to our course rep in the Google Classroom, so I will ask you. It's okay, I give you some option. 1st of September, it's a Friday. What time? Either 5 to 6:30. 5:30 to 7.
删掉那个圈的话，一个 thumb 给他。
Or 6 to 7:30. Or 6:30 to 8. So there are 4 options. So can you double check your timetable? Do you have class clash with this option? Yes, which one? So this one.
Cannot.
So this one is okay.
Yeah.
Wow.
But
晚上
A bit rush.
Our class end at
6.
6. So your class end by 6. So
Yes.
and then this will be safer 6:30 to 8. 6:30 to 8. Okay, so tentatively I will set this and I will ask another group if everything okay. Then I will put a notifications in on the Google Classroom. Okay. Hi, afternoon. Okay, so the chapter nobody asked, so you don't want to know lah. It's okay.
Wait.
Huh?
You want to know which chapter cover? Chapter 1, 2.
6.
This is what? Chapter 6. Chapter 6.
Then,
Yeah. Chapter 1 to chapter 6.
so got any guidelines?
Got any guidelines? You pay attention during class, you do tutorial, then that is my guideline. Okay, so I think we should start our class. Today we have quite many things to cover lah, especially in the application wise. I'm going to show you some NLP related applications like algorithms, checkers, paraphrase, chatbot, and so on and so forth lah. So before we start this chapter 6, quick recap for chapter 5. So chapter 5 is about knowledge representation. Right. To represent the knowledge, to organize and to structure the knowledge, and before we do some coding, okay, before we put the coding into the machines, we need to organize our knowledge first. So there are 4 different techniques that we have learned actually from last week: semantic networks, conceptual graph. Okay, so both of these techniques used to represent the relationship and also some sequence of events. Okay, and also we have seen the other techniques like and/or graph to represent the rules, and the last one would be the frame. Okay, to represent the properties or attributes. Okay, so you must know how to draw the semantic networks, and you must know how to create the frames to represent the objects as well as the attributes or properties. Okay, so once we design the knowledge everything here, then only we can build our NLP so-called NLP applications. Yeah. Okay. So let's move on to this topic. So NLP. So NLP here is stands for natural language processing. NLP, under the NLP, there are 2 different 2 branches. NLP. It stands for natural language processing. So under the NLP here, there are 2 categories. It's called NLU and NLG. So NLU stands for natural language understanding. It stands for how the machine is going to understand what user is trying to ask, request, like the search engines, right? We type some string there, so the machines have to process these strings and try to understand what are the objects that the user is looking for. So after the machine understand, then you need to generate. Okay, you need to generate the response to the user. Okay. So yeah, last week we have seen the semantic network. Look at this example. Assume that you go to the Google or any search engine, you type where does Homer Simpson works. So how the machine knows that you're looking for the working place for Homer Simpson? Okay, so I believe that you have gone through the practical of the NLP. So how the machine, how the NLP works is actually, we have to perform a series of pre-processing. For example, in this case, tokenizations. Okay, we have to break this individual word into the small individual tokens, and then we perform what? The so-called part of speech tagging. Right? Let's say now you have a Homer Simpson. Where does Homer Simpson works? Okay, so after we perform the tokenization, we break the words into individual token here. Okay, let's say this. So we have to perform another process called part of speech tagging. The purpose we perform the part of speech tagging is to understand the grammar of each of this word. For example, does is actually a verb. A verb is a verb. Homer Simpson is actually a noun. Okay, where is actually not mistaken, is an adverb. Okay, and then from here, the machine is trying to go back to the semantic networks of in the Google they use a Google conceptual graph. Google has a team to build this entity-based graph. And once we identify this part of speech tagger here, then we have to go back to the entity base and try to find. Okay, so we have a Homer Simpson, right? So Homer Simpson. So you are looking for this object, and then you are looking for these keywords words. And so since we have a word keywords here, then the machines will identify that, oh, you are looking for this entity. Then it will return to you, okay, So you will think in the word from Saha, he works at the Springfield nuclear power plant. So this is how the actual process flow of the search engine works. You need to process the string first, identify what are the keywords, what are the objects that you are looking for. So I'm going to show you one through the Pythons how we can actually do the search here. So back to here. Okay. So let's say now we put we just call the functions in the Python. It's very simple. We just call a function called post tagger, or we call a post tag. So we apply these functions into the sentence. Let's say our sentence is where the Homer Simpson works. So after you apply that, it will show you that where is actually RB. What is RB? Okay, adverbs. So we have Dacia is a verb, Homer is a noun, Simpson is a noun, and word is a noun. In this case, word is something. What is a noun? Okay, by using a NLTK, it shows that word is a noun. Okay, word is a noun. Doesn't matter because we have these keywords and we have these keywords here. Then eventually, we will go back to the semantic network and search for this keyword and return to the response. Okay, so after we perform the NER here, so perform this POS, then we have to perform the NER. Let's say NER. We perform the NER. We would like to know further what is Homer Simpson? It's a noun, but what is this? Is this a company, organizations, a person name, or a brand? So we can further analyze NER, and it will tell us that Homer Simpson is actually a person, right? So further analyze, it's a person. Yeah, so it's a person. Okay, so this is how the search engine works. So we have to perform a list of so-called pre-processing and then to analyze it. But most of the students, they will just apply like in this case, we just call the function post taggers and apply to the sentence. But if you like to further understand what is post taggers, how the post tagger works, then it's good also. It's good also. You have to understand what is the concept behind the post tagger, so that you can customize your own functions to make it more accurate. Okay, to make it more accurate, to improve the accuracy in this. Maybe you apply some sentence, you give a wrong tagger here. Then you have to find out what is the concept behind the post tagger. Is it possible that you can modify the concept behind the this function post tagger? Okay. Yeah. Is that okay? Okay. So maybe I got the time, so I explain a little bit how the post tagger works. Okay, let's say now we have a sentence called he kicks a ball. Let's say he kicks a ball. He kicks a ball. So we know here, kicks here can be actually formed by a verb, but kick here is also can be formed by a noun, the object, right? What is kick? Kick in action, and the action is meaning you kick the ball, right? But in a noun, what is the meaning? Kick. Correct or not? You have a kick. It's some kind of idea. Huh? Why all so quiet today? Are you okay? Look very sad. Okay, so how do we know that this kick is actually a verb or a noun? So how the post tagger works? So this post tagger is using a concept is called hidden Markov model. Hi. So hidden Markov model is actually a stochastic models or using a probabilistic technique to find out the so-called the tagger, okay, using some probability value. All right, so now in this case we will know that he is actually a pronoun. It's a pronoun. So we know the kick can form by two different tagger here. It can be a verb or a noun. So there are two possibilities here. It can be a noun or it can be a kick here. Okay, is actually an article, right? It's an article. Ball is actually a noun. So we know that this will be the form of this sentence. Pronoun followed by noun or kick. Oh, sorry, it's not a kick. It's a verb. then followed by article, and followed by noun. And then we need to so-called find the probability in a lot of articles, a lot of paragraph. We have to fit into the post tagger to learn. So the article, the hidden marker model will actually identify what is the probability in most of the articles. What is the probability that the first letter is always start from pronoun? So we will get some value here, probability. Let's say it's a 0.2. Then we will identify what is the probability that given a pronoun, it will generate a noun. So we will get some probability here, let's say 0.2. Then at the same time, we will get the probability that given that we have a pronoun, what is the probability that it will generate the letter next to the pronoun will be a verb. Then we'll get some value here, let's say this. Okay? And then at the same time, we will find out what is the probability that the article is followed by this noun. So we get some value here, we get some value. Same, we get some value here. Then we will do some multiplication. Multiply here and multiply here. So we will get which one is having the highest value. So let's say this path you give a highest value, then we will know that this key is actually a verb. So you will see that most of the algorithms that I mentioned during the class or during the practicals, they're actually supported by some max. Okay, some algorithms that you probably learned during your secondary schools. So it's good also. AI is not about just to call the functions, but it's about the concept behind each of the function. If you can understand the concept behind the functions, then you probably can customize your own AI application and enhance the accuracy. So this is very important. It's not just to call the functions. I know that all of you just majority of us we just call a function. Like in this case, we just call a function post tagger and apply. So let's say now what happened? Let's say it shows the Homer Simpson is a verb. We cannot do anything because it's sometimes predefined by the post tagger. So if we know the concept here, then we can actually enhance it, modify the probability value to increase the accuracy. Okay. So yeah. So we look at the more example here. Chatbot. Chatbot involve two categories. You need to understand as well as to generate the response. So how the chatbot works? There are many types of chatbot. I'm not sure whether any one of you will be doing the chatbot for your assignment. A simple chatbot is using the rule base. Like in this case, do I have a chatbot? Okay, so this is actually a rule-based chatbot. You probably have seen one of the applications. It's called Eliza in the tutorial, right? So how the tutorial works is, how the Eliza works is actually using a rule-based. It's where we just key in a keyword here. So if let's say the user key in this keyword, then the chatbot will respond this to you. If the user key in this, then we will have this response. So, but if let's say we key in something that's out of this four rule base here, then it will show you, okay, I'm sorry, I don't understand. Can you please clarify? So let's try this chatbot. So I don't think we have this kind of chatbot anymore. So it's not efficient, and probably the user is very annoying to use this kind of chatbot. Okay, so hello, I'm chat with you. So make sure that the input must be follow the keywords here. So you can just type hello. Then it will show you, oh, hello, can I help you? So you just respond, hello, how can I help you? It's based on the keyword. Okay, what is your name? No pace. What is your name? So I'm a smart bot, you friendly chatbot. I'm trying to key in something that is out of this rules. So I just type hi. So you say, I'm sorry, I don't understand, because hi is not within their rules. Not within their rule base here. So it will show you that I don't understand. So how can you please clarify? So if you want to build some chatbot, don't use this method anymore. Probably you can use smarter ones instead of using a rule base. Probably you have to use some machine learning base of chatbot let's say you can use a GPT-2, okay? So GPT-2 will learn the data set, okay? So how to make the chatbot is become smarter? So we have to pump a lot of data set, right, for the machine to learn. Let's say in this case. So, okay, so I'm going to use some machine learning based to teach the machine. If we have see this keyword, then this will be the response. If you see this keyword, this will be the response. So I have to run this first. Okay. So assuming that in this chatbot, I have three topics. One is about weathers, one is about joke, and another one is about recipe. Okay, so I'm trying to key in some questions and where I have this keyword. Let's see whether this chatbot is able to return the correct response or not. Okay, all right. So let's say, hi. What is the weather today? What is the weather today? So it will tell me, okay, the weather today is sunny and warm. So if you compare to the previous ones, it's better, right? It's based on the keyword, but it doesn't matter like what kind of words that you ask. But as long as in your sentence you have this keyword, then it will return the correct response to you. What is the job? Okay, I am a bit moody today. Can you tell me a joke? Okay, do you know what type of bee is the most annoying?
蜜蜂，
Bee sing,
蜜蜂，
you know?
它会吵灯。
Good job, okay. But you not smile. You not laugh. Okay, so you can see that this bot is quite smart lah. Based on the keyword. No matter you have a, let's say I have some typo errors here, but it doesn't care. Just look at this keyword. But you probably can improve, enhance this performance by not just based on the keyword, okay, not just based on the keyword that I set here. Maybe you can put more keywords that related to the values by using the what? By using the word net that I show you last week. Okay? Yeah, I think no more. So we go through the next one. So anyone building your chatbot for your assignment? No. Yes, you're doing a chatbot. Doing chatbot. Okay. So make sure that I want to see something like this. It's not based on the rules. Okay, the rule base is already outdated. We no longer use the rule based chatbot nowadays. Okay, so you can see that now more chatbot is being applied in most of the platform. Let's say the bank here. Okay, so even you can apply the credit card using the chatbot. Last time we need to contact to the customer service, right? We need to talk to the customer service. Okay, I would like to apply some credit card. Then you need to provide all the so-called documents for the so-called the staff to process. And even you want to terminate the credit card is very troublesome. Back to the many years ago, you want to terminate the credit card, so the staff you need to verify, and then the staff will keep like persuading you not to terminate. So we will offer this and that. But in this case, you will see that I will just put, okay, I would like to terminate, apply this one. This one is apply. Oh, there's no terminate. A month ago, I just terminate through the chatbot. I say I want to terminate. So you just ask me, okay, can you provide me the username and password, and then not password, the username and some details. I provide, then it will just automatically terminate the credit card. So you can see that it's very convenient compared to the toast time. Okay, so you would like to build a chatbot. There are many platform free platform for you to build a powerful chatbot. For example, this word not Flow or Panda Robots is one of the famous chatbots that you can use. Okay, spelling collections. I think this one you should know. So spelling collection also available in. I like to say by first. By. Okay, goodbye. Have a nice day. So do we have a this one? Okay, spelling collection. Spelling collection is very simple. In the Python, you can just call a function called textblock. Okay, so textblock is one of the famous library that deal with the natural language. So in this case, let's say I have a sentence called "I love to attend artificial lecture." So this lecture I purposely make some typo error here. So I said I never. So this is any never sleep during the class. So there are a lot of typo errors. So let's see what happens if I just apply the text block here. So that will be the output. You will see that it clean the text, right? So it's able to return the correct output. So the lecture here become, this is also a lecture, yeah, the corrected. And never, so this NEBR become never. Okay, CLSS it become class. It's all correct. Except this Python. If Python, the text block detected other words, it show you ton. Maybe he like to eat black ton. I'm not sure. So that is the limitation if you use the predefined functions in the Python. So you will just find the closest word to the word that has an error, then it will return you the closest one. So if you want to enhance the accuracy, yes, you need to understand the theory again, the concept behind how the test probe works. So that is the concept on how the test probe, we actually have to measure the distance between each of the letters and then find out what is the numerical values. And then, yeah, so this one I'm not going to show you, but I just want to pass you the message that sometimes we cannot just call a function, apply and get the result. Sometimes we need to understand the concept behind and try to enhance it. Like in this case, I try to build the on so-called spelling corrections algorithms here. Okay, so I try to run it. So let's say now I have a word called APPEL, so APPEL. So we have these corrected words. So this algorithm here will basically compare this apple with this input words. Okay, compare and then choose which one is the closest one. Then you will return to you. Okay, so the closest to this typo error will be apples. Okay. So more applications like text predictions. Okay, so text prediction is one of the common features that available in your phones, in your WhatsApp. Okay, I want then he will suggest you what are the words that available right after So how this works? So this one we need some training modules here. So I'm going to show you how this text prediction works. A very quick one. Yeah, autocomplete system. Sometimes we call autocomplete or we call as a text predictions. Okay, how it works is very simple. Okay, so I'm explaining this how this works. And let's say we have a sentence. I want how the machines know that that you're looking for these words. Okay, so come back to here. So the first thing we need to train the machine is the data set. Okay, so we are going to pump a lot of text or so-called paragraph or your historical text to the machines. So the machine will start to learn. So how to learn? One of the techniques we call bigrams here. So what is bigram? Bigram means that we are going to teach the machine to learn not word by word, but 2 words each time. Bigram means that the machine will start to learn these 2 words at this moment. I love. It means that after I will be love. Then after that, he will love these 2 words. After love will be natural. Okay, after natural will be language. After language will be processing. So he will start to learn all this data set using bigram. Means that only 2 words each time. So after that, if you have a word called love, so you want to know what will be the word after love. Then he will show you the word after love will be natural. Why? Because based on the data set, he learned that love after the love will be natural. So this is how the machine learns, called bigram. So if you want to improve this performance, you can use trigram or maybe you can use 4 words or 5 words. Okay? So, okay, this one is not very important. Okay, so just now we have seen a question answering board, we have a chat board, a text summarization tool. Okay, so text summarization tool is also one of the famous NLP applications. So there are two types of text summarizations techniques that you can actually use. It's not here, I think from here. Okay, so there are two types of text summarization technique that you can explore. The first one is called extractive. The second one is called abstractive. Okay, extractive is very simple. It's where if we have a long paragraph like this, then extractive we just use certain algorithms to identify which sentence are exactly very important. Then you will just extract. That's why you call extract the whole sentence. So in this example, I'm going to use the extractive summarization. We just based on certain algorithms. Okay, this sentence is very important. Let's say this one. Then you will just extract the whole sentence and pump to you. Okay, company also okay. Then the second sentence maybe is very important, is currently, okay, so this is very important. So it will extract to you. So this is relatively simple compared to the extractive. Extractive is where we need some machine or deep learning algorithm to understand the whole paragraph and then somehow modify the content and summarize the whole paragraph to you. Okay? So yeah, you can consider. I have shown you a lot of these applications. If you want to go for the NLP, then you can do a lot of things. Auto complete system, yeah, spelling collections. You can text summarization tools. There are a lot of NLP applications that you can actually explore for your assignments. Okay. So, but what is the main problem in NLU? Okay, natural language understanding. So the main problem in a natural language understanding is where the communications between each others is heavily depends on how much knowledge do you have in a particular domain. Like if you talk to your friends about politics, but your friend do not have much knowledge information about the politics, probably he cannot understand much about the politics. Okay, so this is the main challenges in NLU. Same goes to the machines. If you don't have enough knowledge pumped to the machines will not understand what you're trying to ask. Okay, so that is the main problems. Look at these examples. Okay, if let's say you have a guy told a girl, okay, I think you are like my whiskey. Okay, so what happened? Let's say there's one boy tell you that I think you are my whiskey. How do you interpret this sentence? Huh? Brandon, yes?
Burn my heart and hurt my liver.
Okay. So Brandon say burn my heart. What?
Hurt my liver.
Hurt my liver. So is this something good or something bad?
Where's my money?
Bad thing. So based on your understanding, it's about bad thing. How about you? How about girls? What do you think? If I have some guys told you this sentence, I think you are like my whiskey. Do you think it's something compliments or something that is like insult you or something? Huh? What do you mean? Let me ask some female here. Yeah. You don't agree that you are female? This is I know. Yes, Chai? What happened? If, let's say your friends, Jackson tell you, okay, I think you are my whiskey. What is the meanings? Hide behind the sentence. Huh? Yes. Okay. So you think that these guys like me. So it actually depends on how well you understand about the whiskey. If you don't understand the whiskey, you probably cannot understand what this guy is trying to tell you, right? So and then you have to relate that this whiskey is actually, in this case, is actually as an adjective. So what happens if you drink whiskey, you actually drunk, right? You're drunk. So maybe the guy is trying to tell the girls that you are so beautiful, you make me drunk. Okay, so that is the main challenge in the NLU. So it's how to convey, how to make the machine can really understand what you're trying to ask, trying to convey. That is the main challenge. So we cannot just like use the meaning from the dictionaries put inside the sentence for the machine. We as a human, we know, right? Based on the environment, based on the situations, we can try to understand the hidden meanings of a sentence, but the machine know, right? So how to build a machine that can actually understand all these things, it will be very challenging. Okay, like these examples, she stole a pair of shoes. Okay, so in the first sentence, it's actually a criminal act, right? You're trying to steal something. It's something bad actions. But how about the second sentence here? She stole my heart. So are these two sentences similar meanings? Are these two sentences similar? No, right? The first one is actually some action. The second sentence is actually an adjective. So how to train the models is in such a way the model can understand, can differentiate. The stole in the first sentence is about the verb. The second sentence is about some adjective. Okay, so that will be a very challenging. Okay, so we cannot merely change together the dictionary's meaning of steal to both the sentences. So instead, we have to apply. So I believe that you have gone through the practicals. We have gone through what the pre-processing, right? We go through the pre-processing. We apply the tokenizations, lowercase, stemming, lemmatizations, and then we do some this called post tagging. Okay, to do the pass tree. Okay, after the post, then we apply the NER. So after NER, then we do a lot of things. So we have to perform a list of pre-processing and make sure that the machine can trying to understand the actual meanings of a sentence. We cannot just simply apply the meaning from the dictionary into the sentence for a machine. So that is not true. Okay, that's why I keep emphasizing on the techniques, the process flow, the pipelines in the NLP. Okay. So some symbolic analysis. This is very important. Some important analysis in NLP, beside the tokenizations, beside the so-called lemmatizations, there are some symbolic analysis in NLP that you must so-called take into account while building your NLP application. The first one is called morphological analysis. What is morphological analysis here? So morphological analysis is one of the important analysis in the linguistic, where it tries to understand the so-called the smallest unit of a word that build a certain word that carrying a meaning. For example, you have this unhappy. If you use a tokenizations, unhappy will still become unhappy. This is one word. But if you apply morphological analysis, so we will break this sentence, okay, this word here, into a smallest unit. This is a smallest unit, okay, called un. This is actually so-called what? I'm not sure whether it's not infracted. Some components This happy will be another word. So this un here has its own meaning. This happy has its own meaning. So this smallest unit is called morphemes. Okay, this smallest unit is called morphemes. So why is it important to apply the morphological analysis onto a sentence, into a words? Because we like to know what are the smallest unit words that can actually build that words here. So this unhappy, how do we know that this unhappy is actually something negative? Because we know that happy is something positive, right? And then we know that un is something is like inward. Then we apply this whole sentence, combine these two morphemes, it becomes something negative. It is very important to apply morphology analysis, especially you want to study some so-called sentiment analysis. Then morphological analysis is very important. Okay. And some others symbolic analysis like prosodic phonology. Prosodic phonology analysis are applied to sound-based NLP system. For example, Siri. For example, waves that produce a sound that need the sounds from the human to generate something. Okay. Prosodic analysis is related to emotions, rhythm, and intonations of language. Let's say these examples. We have two different sentences. Okay, so we have a first sentence called "Same got an A in calculus." If we just pronounce this "same got an A in calculus," so the machine will treat this sentence as a sentence, as a statement. as a statement. We know that the sound is actually formed by a wavelength, right? Wavelength. So that will be the wavelength. So this is the sound, let's say. So let's say you pronounce same got an A in a calculus, so you will have some wavelength here. So we know that if by using this certain threshold, or you calculate the so-called the fluctuations of the wavelength, then we will know that the emotion of this first sentence is actually just a statement. But if you try to change the tone in the second sentence, which is same got an A in calculus, so you have some peak here. So the moment you pronounce this second sentence, it become like sound, okay, same got an A, something like this. So by analyzing the wavelength here, or the peak, then we will know that in the second sentence, it is more about unbelievable. The feeling will be different. So this is how we train the models to learn whether this sentence is just a statement, or whether this statement is like a questions, whether the humans, right, the person that taught this first sentence is what feeling, is it in a calm feelings, or the second one will be a bit so-called excited, okay. So this is one of the very important analysis. Prosody is about intonations. Whenever you want to build a smart home, you need this analysis also. Okay, so yeah, so there's some other example lah. Let's say you look at the third one, I hate assignment. Let's say I just say I hate assignment, so it means that I'm quite hate. I'm still okay, but I a little bit hate of assignment. But let's say you say, okay, I hate assignment. Based on the peak, or based on the wavelength, then we know that what is the emotions about the assignments. Okay, and then the next one will be the phonology. Phonology is a branch of a linguistic analysis, mainly to study the so-called accent, to study the accents, to study the sound patterns. Okay. The phonology is to study the sound patterns in different languages to convey something. Okay. Different people from different nations will have different accents, different pronunciations. But how are we going to train the machines that can transcript the different accents to a similar words? For example, in this case, croissant. Okay, how to pronounce this word? How to pronounce this word? Croissant. How to pronounce this? In Malaysia, as a Malaysians, how you pronounce this word? Croissant. Croissant. Okay, so you see, you pronounce croissant. You pronounce croissant. Okay, let's see how American pronounce this and how British pronounce this. How to pronounce? Okay, so this is British accent.
Croissant.
They pronounce croissant.
Croissant.
Okay. How about American?
Croissant.
Croissant. So you see that different people, even we don't talk about the British or Americans, even this one group of people, you have different pronunciations. So how to build, or how to teach the machine where it can recognize croissant, all as these words. That will be another challenge. Okay, so it's not easy, but it's doable. It can be done. Yeah. So you can apply this. If let's say you would like to build some things in your FYP you would like to build some system that deal with the sound, then you can propose. You can propose that in your one of your objectives is to apply this phonology analysis. Okay. Then you tell your supervisor, I have this AI module inside your FIV module, inside your FIV project. Okay. So these two also another important analysis in NLP. The first one is called syntactical analysis. So syntactical analysis is more towards like the post The post is to study the syntactical structure, to study the grammar, the grammar of each of the words, right? What is the grammar of each of the words? So this is syntactical analysis. Semantic analysis is more towards to study to understand the meanings of a word. Okay, what is the meaning of this kid? What is the meaning of this ball? What is the meaning of this what is the meaning of this he? So remember the machines cannot understand the words. Okay, how they understand? They understand based on the comparison, based on the relationship, using what? Using semantic network. Last week we learned about cake. Cake is what? Cake. How do you relate cake to what? Cake is a word, maybe a cake is what? And then a ball is what? Round. Okay. So this is how the machine learns. So after we understand the syntactical structure, then we have to further analyze what is the meaning of each of the words by comparing the concept surrounding the object. Okay, so this is very important as symbolic analysis. So we will further analyze what is syntactical analysis using a past three later. Okay, so one of the common problems that you may face in one of the main challenges that you may face in the NLP is called the ambiguity. So ambiguity is something that is not sure. Okay, ambiguity. There's something not sure in NLP. So there are two types of ambiguity here. It's called semantic and syntactic. Okay, so what is semantic ambiguity? Semantic ambiguity is where in one sentence there is some words that consists of more than one meaning, but the structure remains the same. But just some of the words inside the sentence are similar. For example, in this case, meet me at the bank. Okay, meet me at the bank. Okay, so the structure doesn't change. Meet is a verb. Okay, me is a what pronoun. At is a prepositions. There is a determinants, and then bank we have is a noun. But you look carefully here. Bank can have more than one meaning. Bank is referred to the financial bank here. Bank also refer to the river bank. Okay, so which one do you refer to? Is it finance or is it refer to river bank? So this is so-called semantic ambiguity. One sentence you have one word that's more than one meaning, but how do you train the machines that the bank is referred to this or this? So that will be one of the challenges. So I believe that you can solve it using a machine learning technique lah. Okay, but I'm not going to cover in our syllabus. There are some solutions. So there is another ambiguity is called syntactic ambiguity. Syntactic ambiguity is where you have a one sentence, but this sentence could be formed by multiple syntactical structure. Okay, there could be more than one syntactical structure. For example, in this case, they are hunting dog. Okay, so they are hunting dog here. Are you referring to they are hunting the dog? Okay, hunting means that are you referring to hunting? They are hunting dog. So are you referring to a verb? So this is a verb. Or are you referring to hunting dog? It's a species of a dog. So this is actually a noun. So this one will totally change your syntactical structures. Okay, if you have a different syntactical structures, then the machine will interpret this concept differently. So how are we going to so-called make sure that the machines that can identify whether you are referring to the verb or are you referring to the species of a dog? Okay, so later on I'm going to show you how to solve, not how to solve, but how to identify the syntactical ambiguity using a past tree. Okay, so can you look at this sentence? Thor hits Captain America with a hammer. So, can you identify what is the problem with this sentence? Thor hits Captain America with a hammer. What is the problem with this sentence? Anyone? No problem. Brandon sleeping, it's okay.
One is Thor hit America with a hammer. One is Thor hit Captain America have a hammer.
Oh yeah, okay. So it means that the Thor, very good. So it means that the Thor here. So this is Thor. So we have a Captain America. So this is Captain America. So using a hammer, and then hit the Captain America. So that's the first meaning. Okay. The second one is you have a Thor. Okay. So this is Thor. So this is Captain America. So Captain America is holding a hammer, and then Thor hit the Captain America. Okay, so you have two totally different statistical structures in one sentence. So even as a human, we also cannot differentiate whether in this sentence is it refer to Thor holding a hammer, or is it refer to Captain America is holding a hammer. So how do you expect the machine knows that which one is holding a hammer? Is it Captain America, or is it Thor is holding the hammer? Okay. Maybe I can show you some technique how to solve this semantics ambiguity. Okay, look at this sentence. Let's say we have this sentence. He presents his work to boss. Okay, so in this sentence here, we have semantic ambiguity. Why is the semantic ambiguity here present? Okay, so this present, are you referring to a verb presentation? Or are you referring to a noun? Okay, is some gift. Okay, so how to solve this one? How to inform the machines that the present here is not present? Okay, so we had to perform a series of pre-processing, as I mentioned earlier, tokenizations. After you apply the tokenization, we apply the part of speech tagging. So after you apply the part of speech tagging, then we will tell you that he is actually a pronoun. Okay, and then present here will be a verb. Okay, his will be a pronoun. Okay, work is actually a noun. To is actually prepositions. Boss is actually a noun. Okay, and then by having this so-called parts of speech tagging, then we can actually build a semantic network. Okay, so use the technique that you learned last week. So let's say we have a present. Okay, so this is the so-called agent. So we have a he here. Okay, present. What is the object? Work. So what is the so-called listener? Maybe it's a boss. Okay, yeah. So by having this semantic network, it's very clear that present here is actually a verb. Is the concept here. He present the work to the boss. Then we can actually extend this semantic network to like presentation skill. Like what are the skills that do you need right in your presentation skill? What are the outfit for the presentation skill? So by having these techniques here, then the machines will know that the present here is referred to the presentations. Then you will put this sentence into the search engines. Then it will probably return you what are the skills to have a better presentations, what are the outfit that you need to wear during the presentation. Instead of it will return you the gift, the present information to the user. Okay, so that is one of the solution how to tackle the semantic ambiguity using the so-called part of speech tagger. Okay, there are many solutions to solve the semantic ambiguity. So this is just one of it. Okay, so let's look at these questions. Rambo lifted the man with one hand. So is this a semantic or syntactic? Rambo lifted the man with one hand. Syntactic. Okay, yeah. So means that whether Rambo is only one hand, lift the man with only one hand, or either the man is the OKU, so with only one hand, and Rambo lifted the man. The second one, she stole the patient's heart. This is a semantic. Why semantic? because the stove can be have two different meanings, right? It can be a verb, you steal, right? Another one is about adjective. So the second one will be semantic. The first one will be syntactic. Okay. So I hope that it's very important that you must know how to differentiate whether it's a semantic or syntactic. I'm going to show you some past year question. Let me see. Okay, so this one I will keep it later. So another two types of symbolic analysis will be the pragmatic analysis. So this pragmatic analysis is the higher level of NLP analysis. It's where we have to understand the meaning beyond the meaning from the dictionaries. You have to combine the so-called environments. You have to combine the speaker intentions and a lot of factors to interpret what is the actual meanings or the meaning hidden behind the sentence. Okay, let's say I give you one situation let's say what for you? What is the name? Thomas. How about you? Lucas. Nicholas. Okay, Thomas and Nicholas, they are both good friends. They are both good friends. They stay in the hotel for many years. Thomas and Nicholas. They stay for many years already. Okay, so one day, okay, the window is open and then there's a heavy rain outside. So Thomas tell the Nicholas, say, hey, Nicholas, can you help me to close the windows or not? Okay, so the Nicholas go and close the windows but at the same time, he go and make one hot Milo for Thomas. Because they are good friends. They are best friends for 10 years already. The moment Thomas say, hey, can you close the windows? The Nicholas already know that besides close the windows, he knows that Thomas is very cold. So he will do something like, for example, make the hot Milo for Thomas. He knows what is the extra additional meanings behind the sentence. Why Milo? It's okay, Nescafe better. There's some story about Milo. Okay, Nescafe. So that is about pragmatic analysis. Is how do you train or make the machines know the actual or the additional information behind one's sentence. That is the most difficult one. Okay, sarcasm, another one. Right? So you're so clever, so smart. But in fact, you're not actually compliments the person that you're clever, but you're actually jealous. But how to train the machine that actually you're having this kind of feeling instead of a compliment, right? So that is another challenge. So, but I believe that you can use the deep learnings to solve this kind of, but not 100%, but you still can use the deep learning to learn the past historical so-called conversations from the user. Okay, try to understand the behavior of a person, and then from there you can actually solve the pragmatic depth. But it's not easy for pragmatic analysis. The hidden meaning behind the sentence. Okay, and then we have a word knowledge. So word knowledge is actually like what I showed you earlier on. This one is the word knowledge. Okay, but this is just part of the word knowledge. So you actually have a very big map, a big graph here. It's called Google conceptual graph, something like this. Okay, so it's where it consists of a lot of relationship between each of the entity, between the entity. So normally we as a user we don't build our graph here. We don't build our graph. So we just apply the API. There's a Google Graph. There's an API. You can actually just call the API and use it. Okay. All right. So we have seen a lot of symbolic analysis. So I just revise again. We have a morphology analysis to break the words into a smallest units of words called morphemes, which carrying the meanings. Okay. And then we have a prosody. Phonology is deal with the sounds. We have a syntactical structure and semantics analysis, like the post-dagger and also the semantic networks. And then we have a pragmatic analysis to understand the actual meaning of hidden hype behind the sentence. And then lastly, we have a word knowledge is the expanded versions from the semantic networks. Okay, so these are some of the symbolic analysis. It's not necessary that you apply everything into your NLP applications. It depends on what type of application that you would like to build. If you want to build some sound application like the Siri, then you just apply like the prosody phonology. It's not necessary that you need to apply like the pragmatic. It's not necessary. Okay, so these are the three so-called the must. Okay, the must stage that when you want to apply or build any NLP applications. So definitely you have to go through the parsing analysis, you have to go through semantic interpretation, and lastly is the word knowledge representation. So let's focus on the parsing first. Okay, so what is parsing? Parsing is a technique set to find out what is the grammars of each of the words, and also to find out what is the relationship between each of the words. For example, in this case, Tarzan kiss Jane. So what is the relationship between the Tarzan and the kiss here? So it's actually what is the relation between the kiss Jane is actually a verb for with a noun. Then these two words is actually having a relationship called word phrase. Then what is the relationship between the Tarzan and also this kiss Jane? They are actually noun phrase joined with the word phrase and sentence. It's a syntactical structure. We want to find a relationship between the words here. Okay, so this type of question is very important and how to build a parsing. So I have some questions later on. So after we identify the relationship between each of the nouns or each of the words here, then we have to build a semantic interpretation. We want to identify the meanings. We identify the so-called the grammar here. Then we have to further analyze the meanings. Okay, what is the relationship between word to another? And then finally, we expand these semantic networks into word knowledge representation for like search engine use or maybe for document retrieval purpose. Okay, so what is parsing? To analyze the syntactical structure of a sentence, to identify the major relations such as the subject word, word object, and the noun modifier. Okay, so we have an example here. Okay, so at this, the man bites the dog. Oh, okay. Not the dog bite the man, but the man bite the dog. Okay. So how to build the parse tree? Okay. So normally these rules will be given. Okay. These are the standard rules for each of the words. For example, what is the the? The is actually articles, right? What is the man? Man is actually the noun, right? Bite. What is bite? Bite is actually is a verb. And then what is the relationship between article and noun? So it gives you a noun phrase. So how to build this parse tree for this sentence is very simple. So you can actually from the top down or top to bottom or bottom to top. So normally I will use a bottom to top. So this is how we can draw right the man bite the dog. So the first step is we have to identify what is the grammar for each of the words here. So we know that the is article. Okay. Put ART here. The is ART. Dog is a noun. Bite is a verb. Noun is man is a noun. Okay, and then we try to find based on the rules from the second, third, fourth, and fifth here. What is the relationship between the grammar rules here? Articles and noun give you noun phrase. Okay, so then we try to find what is the relationship between the verb and the noun phrase. Do we have a verb in the noun phrase? Yes, rules number 5. So it gives you a verb phrase. Okay, and then we try to find, do we have a noun with a verb phrase? Noun with a verb phrase? No. So do we have an article and noun? So it gives you a noun phrase. So and then lastly, noun phrase joined with the verb phrase. Finally, you have to achieve this sentence. So that will be the parse tree for this, the man bites the dog. So if you ask me whether is it difficult, no, because the rules is already given. Okay, so you just need to find the combinations between the words. Okay. So why semantic representation is very important? One of the purpose is to solve the semantic ambiguity, and the second one is to solve the canonical form. So what is canonical form here is where you have two different sentences, but they have the same meanings. For example, in this first sentence, I was given this hammer by Thor. The second sentence is Thor gave me this hammer. So you have two different sentences, but they are actually same meanings, right? So this is just a passive form. This is active form. So if you try to represent these two sentences using semantic networks, you will get the same semantic networks. So if you have the same semantic networks, then it shows that these two sentences are actually same meaning. So what is the purpose? Yeah, to solve the canonical
有个
form.
句号，一个点灯。
So what is word knowledge representation? As I mentioned, is the extended version from the semantic networks. Alright, so I would like to try you, I want you to try this question. Okay, John said on Sunday that he would give me a mouse. Okay, look at the question B1. Identify and explain one semantic ambiguity. So in this sentence, you have one ambiguity here, and then you have one syntactic ambiguity. So identify. So one semantic, one syntactic. Each this ambiguity you get 1 marks, and then you have to explain. You have to explain what is the semantic ambiguity and what is the syntactic ambiguity. Okay, so anyone would like to try? Mouse. Okay, yes, mouse is what ambiguity?
Semantic.
Yes, very good. Mouse is semantic ambiguity because mouse is can refer to the ticus, right? Or it refer to the mouse, the computer mouse. How about syntactic ambiguity?
Set on some.
Okay, so you score 2 marks, so another 2 marks. Where is the syntactic ambiguity? Okay, very good. John say on Sunday. Either John say on Sunday is either John say on Sunday or John say on any days that on Sunday that he will give me a mouse. Means that on Sunday I will receive a mouse, or maybe John say on Sunday. Okay, so good. So this one you score 4 marks. It's okay. So how about second one? Given the grammar rules below, illustrate 2 past 3. So means that you have to draw 2 different past 3, past 3 that demonstrate the syntactic ambiguity in the sentence. So if you found that if let's say in one sentence you have 2 different structures, then you are able to build 2 different past 3. If this sentence consists of syntactical ambiguity, eventually you are able to build more than 1 past 3. If you build this past 3, okay, you will build, let's say you have a sentence, you can build only 1 past 3. It means that this sentence does not have any syntactical problem. If you have one sentence but you can build more than 1 past 3, it means that something wrong with the sentence. Not the problem it's the syntactical ambiguity. Okay, I want you to try for question B2 here. Build 2 different past 3 for this sentence. John said on Sunday he would give me a mouse. Don't look at me. You look at me, then I will punch you some pen. Yeah, Thomas? No. Nicholas? Now I know your name. Okay, I let you try first. I give you 5 minutes to try. Then ask someone to try on board. So this vertical line here is stand for or. It means that noun can form a noun phrase. Noun joined with the prepositions give you a noun phrase, or noun joined with the noun phrase give you noun phrase, or determinant joined with the noun give you a noun phrase. So either one of the combinations will lead you to the noun phrase. But one thing you have to take note is you have to follow the sequence. Let's take this example. Noun joined with the preposition give you a noun phrase. You cannot say that preposition join with a noun give you a noun phrase. This is wrong. Okay, you must follow the sequence. I let you try. I'll correct you.
Trying. If you want that. Discuss with your friend. Are you? Are you trying? Are you trying? No. This kind of pen, this one got power. How are you? You want to try this? Don't want to try. How about you?
Still.
You need to try lah. Can lah. Thank you.
就ChatGPT 吧。
几岁？
是的，是的。
抽个右边的他是直接抽着下来，我说我是这样做，我去就不好。
this combination, maybe you try to look for others. Maybe you have a combination, small plus n, join with n. Have to find the have to try to find Okay. Look at the answer. Oh no, already. Just now, I don't know. So I built the one already lah, so there will be another one. So this one you try lah. You try to build another one. There will be another one past 3 available lah. So this is just one of it. So you try another one. So yeah, this is the second one. Okay, so this one you try This one you try. So let's look at the second faster questions. Provide one applications of NLP and NLU and 2 challenges to build a provided applications. So what applications? Just like I showed a lot. Give me one. 6 mark here. You have one applications. Try to relate this to your maybe mobile, what you have learned, what you are actually using. Google, yes, Google, one of the applications, search engine. You don't put Google lah, search applications, right? Search application. What are the 2 challenges to build the provider applications? So just now I mentioned a lot, right? You have an ambiguity. Okay, is one of it. So consider a sentence: the murderer killed the victim with a bat. Okay, the murderer killed the victim with the bat. Syntactic and semantic ambiguity are commonly found in natural language processing. Identify and explain the type of ambiguity in the sentence. Okay, so do we have a semantic ambiguity here? Semantic. Bat, very good. So bat, it can be the baseball, the bat, right? The make of the wood one, right? And then another one is with the animals, right? So there are 2 meanings. How about syntactic ambiguity in this question and in this sentence? You don't know good or you're not sure?
要考的话，
Any syntactical ambiguity in this sentence?
那一个是中，对，没有中。
Yes, Brandon. Which one? Yes, very good. With the bat. So we are not sure whether the murderer is with the bat or the victim with the bat, right?
是
Then yeah,
一样，
Thomas,
中，
bonus.
那现在是
Again, give the grammar below, but in this case, it just illustrates 1 past 3. But in case you could have 2 past 3 in this case because you have syntactical ambiguity. But fortunately, it just asks to build the past 3. So those who have the pen, I leave it to you for the second question. I already showed you the first question here, so I'll let you try with the second one. Here, we have an empty board. if you have a volunteer. She looked at me and smiled. She's very confident. Ah, yeah. I'm looking at you. Why this one?
你们那个大学有 WiFi 吗？那个的。妈的，这个死学校烂的要死！哎呀，连不到 WiFi 了。没有好 WiFi。放我妈的。那你放去哪？他还是叫班的，是没有 reply。没有 reply 到，我自己都拿不到。
想做一个。那这边找到 MVP 啊。是的。提大学。啊？提大学。S Z S 大学 Z 大学。麻烦了。不是放松。鸡巴。妈吃了。乔伊，你要吃什么？
Able to get the same answer. Okay, yeah. So I'm not going to check that means it's correct. PDN is a PP and P PP phrase now phrase PD phrase DN is now phrase. Okay, good. All right. So sometimes you may see this kind of combinations. Look at this lah. So this is another questions. You may see that you have a bracket here. So what does it mean? It means that it's optional. So the meanings of this bracket shows that you can have det joined with the noun. Noun is a must, right? Give you a noun phrase, or you can have a noun itself give you a noun phrase, or you can have a det joined with the adjective, joined with the noun, give you noun phrase, or you can have a det. ADJ and PP give you noun phrase, or you can have noun joined with the PP give you noun phrase, or you can have ADJ Now PP give you now phrase. So these are the different combinations. Based on the rules number 2, the bracket means that it's optional. So this rule, this grammars is optionals appear inside these rules. Okay? So now you have these brackets. John with his friend. So since we are here, let's try this question. Semantic network frames. Okay, so this one you can just ignore. So this one is the previous chapters. Jack jogs with his friends in a black t-shirt. So we have a semantics. So do we have a semantic or do we have a syntactic in this question? Jack jogs with his friends in the black t-shirts. I don't think we don't have a semantic. Because each of these words has its own meanings, but we have a syntactic ambiguity where whether Jack is in a black t-shirt or the friends is in a black t-shirt. Yes. Okay, but if not mistaken, a lot of students they simply come up with a semantic ambiguity, but in fact you don't have a semantic ambiguity in these questions. You have only syntactic ambiguity, but you don't have a semantic. Okay. Develop 2 past 3 for the sentence provide question 2b. With the use of grammar rule is the figure number 2. Okay, yeah. Yeah, so you have a pen, you still have a pen, but okay. I give you 5 minutes, 5 to 10 minutes. So even you have a D here, NLP consists of 2 number of important phases. 2 of them are syntactic analysis, another one is semantic analysis. So differentiate between syntactic and semantic. So if you still remember, the syntactic is to study the syntactical structures, right? And then we assign the grammars rules to each of the terms, and we would like to find the relationship in terms of the structures between the words. So meanwhile, the semantics is mainly to study the meanings of the word by comparing the relationship between one concept to another concept. So one of the examples is we use semantic networks to understand the concept to the relationship. Okay. So if we look at this question, is nothing like. For question 2, I will expect the student to score 20, about 20 marks from here. Okay, done. Okay. you.
你知道吗？
Question 3 and question 4 will be a little bit tough. Okay, so try to score marks from question 1 and 2. Okay, thank you. How about yours? Same? A black t-shirt with DC, ADJ, and give you an P, give you P. This one is okay. P and P. Give you PP, okay. His friends. His friend DTN give you NP. Okay, so this is correct. So P plus NP. P plus NP give you PP. Okay, very good. VPP PP. Okay, VPP PP give you PP. Okay, NP give you, yes, very good. So you may have different past 3. As I mentioned, these questions consist of syntactic ambiguity. So it means that you can build more than one past 3 from this sentence. If you have different past 3 than this one, don't panic. Maybe yours one also correct. Okay. So any questions so far for this chapter? All good. Okay. So it's good then. If no questions, then that's all for today. See you again next week. So remember, on the 1st of September, Friday, tentatively we have a midterm test at 6:30 to 8, tentatively. So I will double confirm with different groups, and I'll put an announcement on the Google Classroom. Okay, thank you.